Hi crew! Tonight we're going to be talking about adding fractions with unlike denominators, 11-3. I'm going to teach you 3 methods for finding the common denominator, which is a really important step when we have to add fractions with unlike denominators. So let's just get started right away. I'm going to start with method number 1. You read the method while I write the problem. So number 1, I'm going to do 2/9 plus 2/3. Now, hey, get back on there. You knew from last night that you cannot add fractions if the denominator or the bottom number is different. So we have to fix that. And we talked about this in class today. This is why I always make you stack your fractions, because this is like the curtain. And before you go on stage, you do all your changing around in the back. So we're going to make equivalent fractions. We're not going to change them, the value of them. We're going to make equivalent ones, though, that are equal to this. The catch is they have to have the same denominator. Okay, we want to have common denominators. All right, so the first trick I taught here was check to see if one of the denominators is the common one. All right, so we're doing this one right here. What I mean by that is I want you to look at the denominators and think about this. If I were to list out the multiples of 3 and the multiples of 9, you always look at the larger number and say, is this 9 in the 3's times tables? Well, it is. So automatically you know that this is the common denominator. So 9 is the common one. And your book will do this a lot, so really watch for this. Always check, see if the larger number, now you know it's not the smaller number because 3 would not be in the 9's times tables, but 9 is in both of these times tables if I were to list them out. Just try to find the common multiple. All right, from here, it's the same old routine of finding equivalent fractions. Now, I'm writing it this way because you remember we did these problems like this quite a while ago, where I made you find the mystery number here. And all you had to do was multiply, because it's going to a larger number, from a smaller number to a larger number. So I'm going to do it down here. 3 times what gave you 9? Well, 3 times 3. And what you do to the bottom, you do to the top. Okay, so 2 times 3 is 6. So that would be our new equivalent fraction. Now I have to fix the top one. But look, it's the same denominator. So all I have to do is bring over the 2, because I didn't have to change this number at all. Now mathematically, if you wanted to see it happen, here's how it works. 9 times what gave you 9? 9 times 1. What you do to the bottom, you do to the top. I was hoping you were saying it at home. 2 times 1 is 2. Now I'm ready to add. So I just bring down the original denominator, 9, then I add 2 plus 6 is 8. All right, is the problem over? What? Can't hear you. Not until you check to see if this can be reduced. Well, nothing goes into both 8 and 9 evenly, so yep, this is over. This is in simplest form, and I ask that you always circle your final answer. So this method, check to see if one of the denominators is the common one. Always check the larger number, see if it's in the smaller number's times tables. One of my favorite methods to finding common denominators. All right, the next method, we're going to multiply. You read the rule and I'll write the problem. All right, you ready to go? So on this one, it says multiply the 2 denominators, but be sure to reduce the answer. One of my favorite tricks, and this one works really well. To find the common multiple, you know in the 4's times tables, eventually you're going to get to 4 times 5, and they're going to have that in common. And in the 5 times tables, eventually you're going to get to 5 times 4, and then they'll have that in common. So we kind of speed it up. We take the 2 denominators and we just multiply them, and that gives us 20. Because they both have 20 in their times tables. Now I just have to find the equivalent fraction. Find the numerators. 5 times what gave me 20? Well, it was 4. We just did it. What you do to the bottom, you do to the top. I left a dramatic pause because I know you're saying that at home, right? So 4 times 2 is 8. Now up top here, let's fix this one. 4 times what gave us 20? And that would be 5. What you do to the bottom, you do to the top. And 3 times 5 is 15. All right, so here we go. We need to add. I bring down the original denominator, and now I add. 5 plus 8 is 13. Carry the 1. That would be 23. Oh, yikes. What's wrong with this problem? It's improper, meaning the numerator on top is larger than the denominator. You cannot leave it like this. That means we have to turn it into a mixed number. Now let me remind you how to do this. You take the bottom number and you divide it into the top number. Now I have a whole video on this, so you can review that if you forget. So how many times does 20 go into 23? If you said 1 time, you are correct. I know, it's a kind of easy one. Well, how many's left over? We went in 1 time and this was only 23. We could do this mentally in our head. There are 3 left over, and we would put that as the numerator. And then you just bring over the original denominator. That is how you take an improper fraction, turn it into a mixed number. That's it. Now, you still have to check. Can 3/20ths be reduced? Is there a number that goes into both 3 and 20? Well, nope, there isn't. So this is your final answer. Ah, it went away. Well, that's okay. I needed the space anyway. Here, I'll write it down here. 1 3/20ths. Final answer. Let's see if it'll stay. There we go. All right, the last problem. Let's try it. Find the LCM. Now, this is how you're going to do the problem. This is the original intent, was finding the LCM. That's how you find, that's how you solve adding fractions. So you watch as I write this problem down. 1/6 plus 3/10. Now, when I'm doing these problems, I'm thinking to myself, try step number 1. Is one of these is one of the denominators the one they have in common? Well, I look to the larger one. Is 10 in the 6 times tables? No, it's not. Okay, so that method, number 1, doesn't work. Oops. Should I just multiply the 2? Well, I could, but I know for a fact that's not the lowest one. I mean, it could, I would get the same answer. But let's go ahead and find the LCM. So what I would do in order to do this, to find the LCM, I'm going to list out the multiples of 6 and the multiples of 10. I'm going to get the lowest common multiple. I'm going to start with the large number because I know it's going to be much faster. 10 times 1 is 10, times 2 is 20, times 3 is 30. Now, if you are thinking while you're doing this, you know that 30 is in the 6 times tables. So let's quickly find it. 6 times 1 is 6, times 2 is 12, times 3 is 18, times 4 is 24, times 5 is 30. There it is. They have 30 in common. Do they have anything else lower in common? Nope. So that means that 30 is the lowest common multiple. So I'm going to have that as the denominator. And now I just have to figure out equivalent fractions. So let's try it. So 10 times what gave me 30? 10 times 3. What you do to the bottom, you do to the top. By the way, you better be saying that at home, like you do in class. Now let's do the top fraction. 6 times what gave me 30? All right, that's 5. And what you do to the bottom, you do to the top. So 1 times 5 is 5. All right, now we're ready to add. So I'm going to bring down the original denominator. I might as well do it in red. Get it all color-coded down here. Original denominator is 30, and I have to add. 9 plus 5 is 14. All right, now I got to think to myself, can this be reduced? Is there a number that goes into both 14 and 30 evenly? Well, I know they're both even numbers, and when they're even numbers, 2 can always go into them, so let's try it. So let's divide. 2 goes into 14 how many times? 7 times. What you do to the top, you do to the bottom. 2 goes into 30 how many times? 15. Because 15 times 2 is 30. All right, now we're left with 7/15. Is there a number that goes into both 7 and 15? Nope, that is your final answer. It's reduced to simplest terms. Now you might be wondering, could I have done this using method number 2, where I did just multiply the 2? Well, let me do it really fast for you. I'm not even going to talk, just watch. And you say it in your head as I'm doing it. I don't know if I can stay quiet this long. So if I were to multiply them, it would be 60, right? 6 times 10. See, I already can't stop talking. All right, so I want to times 10 times 10. That would be, kind of squished. Times 6 times 6, that would be 18. Look at me, I didn't even fill in the whole problem here. All right, let me add. That would be 60, and then that would be 8, 28. No, I just have to reduce now. Well, let's start reducing. What goes into 28 and 60? Okay, I'm going to do 2. I'm just going to start small, see where we go from there. All right, so 2 goes into 28 4 times, goes in 1 time, and then 2 goes into 60, goes in 30 times. Oh, look at this. Does this look familiar? Does it look like that? Uh-huh. So I don't even have to keep reducing, although I better, because you have to reduce. You can't leave it in that 14/30. You have to keep going. So here is my final answer. What is the difference, though? If I would have just done number 2, step number 2, and just multiplied the 2 denominators, the difference is right here. The difference is in all of this reducing you had to do. You had to do these 2 extra steps. And like I said in class, if you're good at reducing, fine, do that. But we had some hard numbers today, so you need to think about that. I hope this made sense. I hope this helps, and do lots of reviewing on this. Have a good night.